This video is about direction fields. Okay, first let's consider differential equation dy dt equal to fty. All the equations we're going to learn in this class, it pretty much can be written in this form. Okay, now let's see what is a direction field for the given differential equation. Now, let's see the special case of this dy dt equal to tt. First of all, this is a differential equation because this is equation with a derivative involved. Okay. What does the solution looks like for this differential equation? Since this equation is so simple, we can solve it without learning anything. Okay, just as long as you know how to do the integration. Okay. So obviously, y equal to t squared is a solution because if you take a derivative on both sides, you're going to see dy dt equal to 2t. Okay. This is just one solution. In general, t squared plus 1 will be another solution. So in general, plus any constant will be a solution because if you take a derivative of a constant, it gives you 0. Okay. So if we plot all the solutions of this differential equation, okay, they are a group of parabolas. Okay. So the first one, y equal to t squared. And for example, like C is 1. Then you got another parabola, and then you will see equal to minus number. You got like this. Okay, you got an infinite many parabolas. Okay. For each parabola, at every point you have like a tangent. Okay. So you have a tangent here, tangent there, tangent at every point. And you can do that for each curve, each such parabola. With infinite many curves, we can get those tangents at every single point. Okay. All those bars, small bars, they form what we call direction field. So, what is the direction field for the differential equation like dy dt equal to 2t? It's like this. Okay. Now, the direction field, you can find your direction field even without solving your differential equation. For example, like this one, without solving that, we can plot its direction field because what do you need to do? You plug in your t and the y, then you find your dy dt. Okay. Which means you got slope of the tangent for the given curve. Okay. The solution for this differential equation is a curve. Okay. And dy dt gives you slope of the tangent. Okay, now let's look at example. Say dy dt equal to 1. Okay. Now let's plot the direction field of this one. So here you have t, here you have y. Let's just have some numbers. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So for example, like this point. So for this equation, you have f t y equal to 1. And so at the point 1, 1, at this point, you plug in. Okay. Now, there's no t and no y. Doesn't matter what's the t and the y, they always give you 1. So at this point, you got a 1. Okay. And at the second point, you say f 2, 1, t equal to 2, y equal to 1. Here, you plug in there, you got another 1. So, you got a 1 there, 1 there, 1 there, 1 here, 1 here, 1 here, 1 here, everywhere. Okay. 1 here, 1 here, 1, 1. Doesn't matter what is ft, they're always 1. Okay. That's what our direction field for this equation. Okay. Now, direction field will tell you what is your solution looks like. For this problem, what is the solution? dy dt equal to 1. What kind of function? Y. You take it into respect to t, they give you 1. Obviously, y equal to t plus c will be your solution. For different c, you got different solutions. You got infinite many. Okay. Obviously, those solutions can be like this. They're all like straight lines. Okay. So your direction field pretty much tell you what is your solution looks like. Okay, now let's look at another example. Now what we want to do is we want to find this is the example. We want to find a differential equation. Let's just use dE. In this form, dy dt equal to ay plus b. We're looking for the differential equation in this form such that all the solutions converge to y equal to 3. Okay. So first of all, y equal to 3 will be a solution. Okay, so what kind of differential equation in this form? Has y equal to 3 as one of its solution. Obviously, we've got many answers. Okay. Now at least do something like this. dy dt equal to y equal to 3. That's the first choice. Or second, dy dt equal to 3 minus y. For both of those answers, we have what? Y equal to 3 will be the solution. Now let's check the first one, okay? The first one, if y equal to 3, let me emphasize, y equal to 3 is not a number, okay? Y equal to 3 is a function. What this function looks like? This is the t, this is the y, okay? So for given t, you plug it in. The right hand side is no t, that means, say here is 3. For given t, your y is 3. For given different t, your y is still 3. So y equal to t give you a line. Okay. It's a horizontal line. This is your y equal to 3. Okay. Now, y equal to 3 will be the solution of 1 because for this y equal to 3, you take a derivative, your dy dt will give you 0. Let's give you left hand side. Okay. What is the right hand side? Y equal to 3. So you replace y by 3. You got a 3 minus 3 will give you 0 too. So the left hand side equal to right hand side. You got a 0. Okay. Similarly, you can check y equal to 3 is the solution of this equation 2, dy dt equal to 3 minus y. Okay. So we got two of those. Which one is the answer for this problem? Now let's look at this question can be answered by direction field. Okay. Let's look at the first choice. Okay. dy dt equal to y minus 3. Okay. Now let's plot the direction field of that. T and the y. Okay. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Y equals 3. Okay. This line is y equal to 3. Okay. So 1y is bigger than 3. Okay. So your f t y here is equal to y minus 3. Okay. So, for example, we'll have like t equal to 1, y equal to 4. So at this point, what is you plug in there, you can find direct dy dt. Y is 4. There's no t there, so 4 minus 3. They give you positive 1. Okay. So the y is bigger than 3. Y is bigger than 3. Then y minus 3 is always positive. So you got a positive, positive, positive. Doesn't matter what is the t. Okay. And the 1y is less than 3. You got a minus. Right? For example, y equal to 2, you got minus 1. Minus 1, minus 1, minus 1, minus 1. And here, same thing. And your y, for example, this is minus 2. You got a minus 1. If y equal to 1, you got a minus 2. So it's negative slope, but bigger. Okay, like this. And here you got a bigger positive, like this. So this direction field tells you for this equation 1, your solution diverge away from the curve y equal to 3. Okay. So your solution like go away like that. Okay. On the other hand, for our second choice, dy dt equal to 3 minus y. Okay. They both have something in common. They both have y equal to 3. This curve as their solution, one of the solution. Okay. Again, remember, we've got infinite many solutions. Okay. You got a t, you got a y. Okay. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So y equal to 3 again is the solution. Okay. Here is y equal to 3. Okay, now let's look at the direction field. Okay, now for y is bigger than 3, say here. At this point, t is 1, y equal to 4. So 3 minus 4 give you minus 1. They go like this. Similarly here, minus 1, minus 1, minus 1, minus 1. And the minus smaller number like this. Okay. For the point here, your y is still bigger than 3, so still got a negative but a smaller negative like this. Here, okay, here your y is less than 3, so you got a positive, 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 and a smaller positive, smaller positive. Positive, positive. So you can see your solution converge to the curve y equal to 3. Okay. So therefore, the answer for this problem is dy dt equal to 3 minus y. Okay. This is just a solution. You can have many.